This is episode number 5 with Arturo Tedeschi. Welcome to the Archiologist Talks. The Archiologist is a collaborative platform that focuses on showcasing worldwide design projects from students and young professionals. This time around, though, we're creating a space to talk about design with the leading architects and designers around the world. Our goal for these conversations is to inspire and influence the young community. We're going to bring in tips, personal insights, and different perspectives of what design really is to each one of us. And I'm your host, Maria Flores. Hey guys, it's so exciting to have you all back for a new episode of the podcast. And today, our guest is Arturo Tedeschi, who, as many of you know, he's an architect, a researcher, and a computational designer. He basically complements professional practice in Italy with a personal research on parametric design. He focuses on relationships between architecture and new design tools. He has published 2 books, Parametric Architecture with Grasshopper in 2011, and one recently called AAD, basically Algorithms Aided Design. And this is a worldwide reference book on algorithmic modeling, which is based on the Grasshopper platform. He has done amazing things during his career. He has worked with Zaha Hadid Architects in London. He founded AT, which is a cloud-based office that offers computational design services. And he has also been the director and teacher of a series of workshops on parametric design, as well as a lecturer for many universities and conferences worldwide. In the episode, we talk about his random encounter with a parametric sculpture that he actually saw in a museum, and that basically changed his whole life forever. After that, he started learning parametric design, taking courses, doing workshops, and he talks about what architects he has always admired. We go deep into the topic of computational design as a new way to assist the designer in a project, and how he sees the future of architecture changing due to all of this. He gives some insights into what his design process is and how he goes through idea, concept to final product, and what the obstacles he has faced through the fabrication process. He talks about his belief about how architecture is not merely building or real estate, but that to him, architecture is about solving complexities in our everyday objects and making our quality of life better. Finally, he gives advice to all architecture students and designers out there, talking about how competition can actually destroy our lives and how to take advantage of the social media. Guys, I am really excited for you all to hear this conversation. It's gonna blow your mind. And if you're into computational design and new digital tools, this is the episode for you. He has so much experience. He's such a creative person and a collaborator, and we're very eager for him to share his knowledge with all of you. So, let the talk begin. Hi, Arturo.
Hi, Maria. Nice
How
to
are
talk
you?
to you. I'm fine, thank you.
It's so nice to meet you. I've heard amazing
Likewise.
things about you from Instagram, everywhere.
Thank you so much.
So tell me a little bit about yourself. You're an architect. Right now you're in Milan.
Yeah, exactly. I'm an architect and also a designer because I work in different fields from architecture to product design. And yes, my work is basically connected with computational design and digital tools for architecture and design in general.
How did you get into that field?
Well, actually, it was absolutely accidental because I was working, as a, let's say, as a normal architect. I was an interior designer actually, and I have this kind of Stendhal syndrome. You know what I'm talking about? When you see or you're experiencing, when you're experiencing a piece of art and your life changes. Actually, I was in London and I stumbled into this parametric sculpture designed at AA school, and it was like more or less 10 years ago, and it changed my life. And when I came back to Italy, I started studying digital tools, and that's all. But it was absolutely totally accidental.
Wow, so before you were an interior designer, do you think
Yeah,
that
absolutely.
has helped you in any
Yeah.
way in parametric design?
Absolutely, because I think that sometimes people they ask me, what you need to understand, what are the topics in order to
Uh-huh.
master parametric design. I think, along with knowledge, of course, of digital tools, geometry, mathematics, and so on, you also need let's say, a practical experience in your field. So if you are a
Right.
product designer, you should absolutely know how to manufacture all the industrial issues and limitations that you have in architecture. We have this main challenge, which is gravity. Every time you need to create something, which is a building
Mm-hmm.
or a bridge, something like this, it's very complicated to manage gravity, to how to put pieces together. So you need a practical experience, and I think that interior designer actually helped me a lot in understanding how create something which looks perfect. For example, when you work in an interior design scale, you need to create objects that are, I always say, better than renderings. And
Mm-hmm.
so basically it helped me in like achieving this kind of let's say perfection in the final output. That to me is very important to get.
And I think also the interior design part, it brings a touch of the human scale into
Mm-hmm.
your design. Maybe perhaps if you
Yeah,
hadn't gone into interior architecture, then
yeah, that's true.
you would be missing the human scale or how people feel in the space. So
Mm-hmm.
that's
Yeah.
also very interesting.
Well,
So
another side effect is that in general, you can complete an interior design project in a relative, let's say, small time. So
uh-huh.
basically, you switch from ideas to reality in a few time, and this is very interesting because you really understand your idea. You can see your ideas turning into reality, and you can also balance the next steps, the next designs. And generally, in architecture, you spend years from design to fabrication, and
Yeah.
sometimes there are, so many influences that they change the design. So it's a way
Mm-hmm.
for also understanding how to balance your hand, how to balance and how to improve your design, because you can really
So
see
true.
the output in a sometimes in a few weeks, and that's very interesting.
Yeah, that's so true. So you basically saw the sculpture and you
Mm-hmm.
said, I love it. I want to do something
I
like
love
it.
it, and I absolutely this. Yeah, exactly. I want to do exactly the same. I need to understand how to create something like this, because at that time my like thought was I cannot do it right now with traditional tool.
Yeah.
With CAD software, I cannot do it
Uh-huh.
with my geometric skills. I cannot do it basically, and so it triggered my curiosity, but also this love for complexity in a way. And so I started studying again by
So
myself.
how again by yourself. So you
Yeah, yeah,
basically
yeah.
learned all the digital software by
Yes,
yourself
I
because there's a
am
lot of people that they
exactly.
sent in questions. They were like, how did he learn
Yeah.
all these digital programs? So how did you do
Yeah,
it?
yeah, exactly. I like to say that I was like Bruce Wayne in the morning and Batman at night, but I was not defending people, but I was like working as an interior design in the morning, and I studied by myself in the night. So,
Oh
well,
wow.
and what I was studying was not only software.
Mm-hmm.
Actually, I think that. Of course, you need some basic of 3D modeling if you want to master computational design, but you also need, mathematical. You need to understand how to mathematically represent geometries, for example. So you need to
Mm-hmm.
understand differential geometries, mathematics, but logic also, with a deep knowledge of 3D modeling. And then you put everything together and you start to, I like to say, to understand the mathematical structure of objects. And so when you can master this, you can also think computationally, mathematically in a way. And so when students, they ask me where to start, actually you need a big curiosity and passion for mathematical representation of reality. And I think this is one of the most important things, along with, the study of digital model tools, digital like Grasshopper, for example, or similar computational design platforms, coding, but tools without strong knowledge of geometry and mathematics is like totally useless, I think.
And that's probably why, now that I think about it, Zaha Hadid was so successful in her career because she studied mathematics in school. That's
Absolutely.
really
And
interesting.
yeah, of course, she was one of my design heroes, of course, and my passion didn't start with the admiration of Zaha actually, but she really changed my vision over the years when after my standout syndrome I was mentioning before, I also started like loving Zaha, the design, her approach, her sketches, her visions actually. And but she was not my like unique only inspiration. I love the work of Ross Lovegrove, which is really innovative, and I really love his work and his approach, how he translates natural like shapes into design, not in a trivial way, not in a cosmetic way, but in a very deep way. So I really love his approach. But I also like, let's say, traditional architects like Rem Koolhaas or Herzog and Emeron, Thomas Heatherwick. I think it's a very, very like talented, and I really love actually his first like projects. I really love them, and also the pioneer in form finding like Fraiotto, or the Italian architect Sergio Musmeci, which is not like worldwide famous, but he designed a bridge in Italy, which to me is absolutely a game-changing like project in the history of architecture. So there are many like references, many heroes,
and
if you like.
Italy has a lot of amazing architects and designers
Yeah,
that came from there. It's awesome, all the history.
yeah, absolutely. And for example, I learned a lot when I was a student from Renzo Piano, which is not strictly computational architect, let's say, but the way how the ability to put together different materials, his sensibility in managing like shapes and materials, it's amazing. It's something that absolutely influenced me when I was an architecture student.
It is amazing, yeah. Do you think then that computation design assists or replace the architect in the design?
Of course, it won't replace. I don't want to use trivial analogies, but well, I actually invented the word AAD, which means algorithms aided design. That to me is like the current stage of digital tools for architecture. I mean, design aided by algorithms. Now, of course, algorithms, they are like they allow designer to overcome the limitations that we have in traditional, software, traditional CAD software, or if we just use our hands. And so they can they allow us to reach a level of complexity which is beyond the human ability, let's say the human manual ability. Probably I repeat myself, but as designers, we use our hands for creating objects. Also, if we are using the computer and a 3D modeling software, we are still using our hands through the mouse. And so basically we have the same limitations of reality. You need to have a manual ability for creating objects and complexity. So with algorithms, you can basically, it's easier to translate your ideas into objects. It's like a direct connection from ideas, from our brain to the object, like switching and passing by the mouse step in a way. So absolutely, it will assist the designer. It's not no need to think about dystopic images of computers stealing our profession and so on. Of course, I think the next step will be absolutely artificial intelligence, AI.
Right.
On the Instagram, we are, and social network in general, we are like seeing algorithms that, in order to create automatic layouts of apartments, for example, or museums, airports. Of course, this is a great help for architects, and of course they won't destroy our profession, but actually they will help us in creating better projects, because we don't have to spend time in trying different configuration. Won't be a trial and error process, but we will be supported by a tool, a set of tools, and machine learning like software, like helping us in doing better projects. So that's
right.
I'm
Yeah, that makes sense.
absolutely positive and confident in technology. Also virtual reality, for example, that right now and nowadays is used for exploring projects, like for architectural visualization, basically. But I think that will be, I actually designed a furniture piece using virtual reality, a chair, and it really helped me in exploring new ways for sculpting the matter, the digital matter in that case. So, but we need to be educated in this kind of new machine human interaction, because basically we are talking about interaction between a human being and the computer. And so, for example, the virtual reality will be crucial. Also, advanced fabrication, new technologies, new fabrication methodologies will be absolutely important. Everybody talks about 3D printing. Is not 3D printing, for example, totally needs, for example, also something that I like to call it the Amazon Prime logic. I mean, the new generation, the so-called millennials, they are used to order something and having it immediately. They are growing up with this kind of attitude. I want something, I want it now. I want it right now. So, for example, 3D printing is something that totally like meet this kind of social postures, this kind of attitude, having something like immediately. So everything is like, today, I think there is this kind of everything overlaps, like social networks, new possibilities, a new way of buying stuff, and architecture and design. Basically, they are not separated from that. They are part of the same, new social posture. And so it's important to analyze all these new possibilities in a holistic way, not just by separating from outside.
Okay, I have a question that I've thought about a lot lately. Let's say that we have quote unquote traditional architecture, like Renzo Piano, Herzog and de Meuron, and then we have computational design. Do you believe that in the future there's still going to be those two separate, traditional and computation, or computation design is going to be the leading in architecture design?
Actually, I have a third way. I always say that probably computational design, I mean, the main goal of computational design is like, is disappearing, but I mean, because probably becomes invisible. I try to explain this sentence. In other words, today or in the past, let's say in the last decades, we saw the cosmetic effect of computational design. If you think about Zaha Hadid buildings, or just as an example, but we have a lot of examples about that. And of course, when you have something new, when you have a new methodology, a new powerful tool, you also want to express the aesthetic of this new potential. I think the next step will be we can create geometries, both in product or architecture scale, informing the design through digital tools. Once again, computational design, AI, and advanced digital methodologies. But they will probably give as a result, let's say, a traditional architecture. I mean, it won't be necessarily something super complex in terms of shape. I always like to say that computational design should solve complexity, not just represent complexity. So probably we are moving to this kind of more mature stage where computational design will solve complexity. So probably the final output will be absolutely, let's say, simple, but a kind of new simplicity. I always think about Apple products, for example. They are super simple outside, they are super complex inside. If you think about the iPhone, it's a super simple surface, black surface. You touch it and you have a word inside. So basically, you need to hide the complexity today. And probably we are going toward this kind of new aesthetic of computational design, where the complexity will be, in a way, will be hidden, will be not in the surface. You won't see the complexity. So basically, in order to answer your question, I hope actually that probably in the next future we will have something which is not the traditional against the complex architecture, but a new species, a kind of new genealogy of design, where we have super complex geometries, but with more traditional, let's say, surface in a way.
Do you think then that there is a particular need for computational design? Because there was someone that asked the question, for example, like, computational architecture is now very popular in India. Do you think there is a need for it?
Computational design is a
methodology. Better said, what is your design philosophy on computational design, and why do you see there is a need to practice computational design?
Well, actually, I think that is a methodology, so it's not connected with style. It shouldn't be connected with style, country, culture, also in a way budget or whatever. So there is a need. Actually, if you want to, as I mentioned before, if you want to overcome the limitations, if you overcome the limitations of traditional design, traditional way of thinking, actually, you need to embrace this kind of methodology. You mentioned if I have, a kind of design philosophy. I actually don't like, in general, manifestos. I don't like architecture manifesto. I think we are not living in a moment where we need, for example, design manifestos. Actually, I'm working a lot as a consultant for companies right now, for many companies in product design, architecture again, automotive as well. And
wow, nice.
I think it's very interesting, and I will probably become, I don't know, maybe my sentence is a bit unpopular, but today, for example, product design and automotive, but product design in general is, in a way, has a larger impact than architecture. I mean, so why it can be a need, computational design? Because I think that since objects, they have a great impact in our life, they should be improved in many ways, because we need to solve complexity with with objects in general. When I say object, I mean a chair, a car that is like moving down the streets, or many things that we have today. So in order to solve the complexity of contemporary design, we need to solve many issues, and which is that are not only the traditional one. For example, of course, ecology, cost saving, but today, for example, we have problems with privacy, data protection. We have a lot of tools that they communicate with outside. So it's very important to understand that when we are creating something today which is connected to the internet, we need to solve also problems that are connected with privacy and with many topics which are not strictly design issues or design problems.
Exactly.
Is something new. So if you want to manage all this kind of complexity, you cannot do it with traditional tools. So is it a need? I think so. Mostly if you open your eyes and if you open your boundaries in a way, if you don't think about architecture just by putting shapes together or just solving traditional problems. Today, I think as a designer, we need to face a new kind of complexity, and only computational tools and design, they can we can face this problem only with computational design.
That's a very beautiful way of looking at architecture. It's been a recurrent theme in the episodes and the podcast that architecture is not just buildings, but it is
absolutely
more. It is something more like solving problems in our everyday lives. Therefore, objects.
Which is changing a lot. It's changing because of we have a new kind of freedom today. We are free to move from a country to another one in just one moment. We have low cost flights. I mentioned Amazon Prime. I mean, we have a new kind of freedom. You want something, you can get it right now. We have the possibility of meeting people in a super fast way. We are talking in this moment.
Skype.
I'm in Italy. It's something. So this is affecting reality, and this is affecting buildings. This is affecting our spaces, and today, once again, and I don't want to be unpopular, in a way, our objects are becoming more and more relevant than architecture itself. It doesn't mean that I don't. I'm not saying that we don't have to take care of architecture
exactly,
of course, but in a new way. We need to have a new vision. We need to understand that things are changing, and architecture is a part of a system, of a connected system. So
I definitely agree.
We need to understand that architecture is changing. It's not only real estate. Architecture is not only selling apartments but we need to reconfigure our spaces according to this kind of new lifestyle that we are. I'm actually studying the new millennial philosophy, and I was reading something that millennials, for example, they are not interested in buying a house. They are more about sharing things. They are not interested in cars, for example. I come from a generation that whose main goals were they were buying a house and a beautiful car. That's all, and you have done. So basically, everything is changing. Architecture is a part of this system. So we cannot think today we cannot design architectures like Le Corbusier did 100 years ago. So we need a kind of more comprehensive and holistic vision.
I definitely agree. One of the last questions that I have for you is, what is your process of design? How do you go from idea to concept to reality, let's call it?
Okay.
Do you do everything on the computer, or do you have other methods?
Well, we need to distinguish between project that has a client and a project that is something like, every architect or like designer creates its own object, pavilions or sculptures and so on. So basically, if it's like something artistic, something which is just an expression of my ideas and so on, I usually start with a sketch, because I still think that a kind of direct connection with a piece of paper is still a very powerful way to express ourselves and to fix our ideas. But that's the very first stage. And well, after it, I turn my sometimes my sketch is not only a way for representing the reality. I mean, sometimes I sketch the relationship that I want to get in my object. So sometimes they are abstract drawings. They are not. It's not something which represent the final object. And then I switch to the computational tools. My of course, everybody knows it that Grasshopper is my second home. Actually, my first. So I live inside the software. So it's. I feel very familiar and confident inside that tool in order to create everything. And basically, I always skip the traditional part, which is creating traditional drawing. I don't create drawings anymore. So basically, I switch from the algorithm into into physical objects according to digital fabrication. So, control milling machines, for example, or laser cutting or 3D printing or whatever. I like to switch directly from the idea to the final product. And this is something interesting because, today, actually, you can liquefy reality into data, into numbers. If you have something created in the computer, which is a sculpture, also a building, basically you can translate geometries into data, into numbers. And so where they are numbers and data, you can transfer them, you can communicate them to manufacturers. And basically numbers are very fast, and very fluid in a way. And so you can put them in this moment. We are communicating because there is a tool that is converting our voices into numbers. They are like flowing through the air, and that's all. And so also I like this kind of vision that everything can be compressed into data, and so basically, that's my process. If I work for a client, in general, the first step, is like it depends on the specific project, but in general, you have to organize tons of meetings in order to set the starting point, and then you have a kind of feedback process, because you move further in the algorithm, and then you create something. You need to double check with the clients, and you go on. So it's a more also traditional way, because you need to speak with people that they don't have, of course, they don't have experience in understanding algorithms and something which is absolutely abstract. So I will distinguish between this kind of two directions. But I don't skip the sketching part. I just skip the traditional,
it's very important.
Traditional drawings, because traditional drawings, they are old. They are old because they are a way of representing reality through abstraction, plans, sections, or perspective, something which is very old. Today we have more powerful tools for understanding and communicating architecture and design.
Yeah. Have you run into any obstacles when you're switching from the computer to fabrication?
Yes, because as I mentioned before, I think that sometimes computational designers, they are very forgiving. Sometimes they create beautiful renderings and objects, and when they switch to the reality, they say, okay, it's good enough. So for me, it's never good enough. I always say that a final object should be better than renderings. So if you want to achieve this kind of complexity, of perfection, you struggle a lot because you need to understand how the material will deform. For example, you can create a super beautiful shape by, bent wooden material, for example, or Korean or something like this. You don't have gravity in your software because there is no gravity.
So true.
And there is not a gravity field. You can simulate it actually, but reality works in a different way. And when you finally create your objects, after one day, deformation, balances, or everything, it will change the object. And sometimes you can see horrible gaps or twisting or something which is like a bad copy of the rendering object. So if you want to create something which is super perfect, you need to have the experience we were talking about at the beginning. You need to have an experience in architecture, traditional architecture. You need to how to put one brick on top of the other. You need to understand how to connect things together, how gravity affects a piece of wood or metal or whatever. You need to have some experience. And so if you have a practical experience, you can predict the behavior in a way when you are creating your algorithm or your design in the computer. So yeah, in general, it's very complicated if you want to do something which is really like, it's better than the renderings. So this is like a quote or something. Yeah, better than the rendering.
Yeah, and I'm guessing the whole process goes from computer fabrication, change something in the computer, fabrication again, change in the computer, fabrication. It's like a loop that you go through.
Yeah, exactly. And I see like online, and I experience many projects that are like they meet this kind of expectations I have, but also many projects that they don't meet at all this kind of like perfection I was talking about. Digital tools, they don't give you perfection in the real world. I mean, it's not direct. It's not a direct connection. You need to master fabrication before mastering digital fabrication, anyway.
Okay, the last question. What is something that you would like to tell a student, a piece of advice, something you wish you knew when you were studying architecture, anything at all?
I think they should create a kind of vocabulary. Basically, every designer, architect is unique, is different from the others. And I think there is space for everyone. I think the first thing that I want to communicate is like forgetting about competition with other people, with other architects. But I think
that's good advice.
Yeah, absolutely. I think that competition is something that can ruin your like professional but also personal life in general.
Yeah.
You need to switch from competitive approach to something more creative. So the first thing to do is like creating your own vocabulary, which is basically made by geometry, your like design references, your heroes, your obsessions, the toys you had when you were a kid, the cartoon you were watching. I think that everyone should dig into the surface. We have like a surface which is created by tradition, by schools, by university, but everyone has something inside. And sometimes you just have to dig and understand what are your unicity. And so starting from them, you can create your own vocabulary. A part of this vocabulary today should be, of course, coding, like visual coding, like Grasshopper, or traditional coding can be C#, Python, whatever. You need to have some scripting ability. Today, it's crucial. Once again, because you cannot manage the complexity with traditional tools. So you need to get into the scripting logic. Then you need to have some skill in geometry. You need to understand, you need to know how to do a mathematical representation of reality in a way. and logic to, and this is this is the technical part, but I mean, you should be very interested in what is happening right now, how digital how social media are changing everything, how the new kind of learning methodology. We have webinars, we have like online courses, we have there are a lot of things all connected together. And once again, design and architecture, they are not disconnected from a smartphone today. In a way, they are on the same level. I mean, we need to design a product or an architecture with open eyes to reality, and trying to understand what the new generation really needs, and not only what professors or university and teachers they
I agree.
told us in the past. And I come from the previous generation, let's say. So I crossed all this the movement.
You've seen everything.
In a way, yeah. I graduated in 2004, and I started my architecture school in 98. So in a way, I saw the transition, actually. And I started without the internet. I started without any access to the information that current generation they are right now. Sometimes students, they ask me, but how can I study all these things today, all this computational stuff, geometrical stuff, and so on? And I always say, you don't have any excuse because you have internet. At my time, when I was a student, I just have one book in my shelf, and that's all about geometry, one about mathematics. So they don't have any kind of excuse, but they have tons of information. So it's important to have. That's why you cannot study everything. You cannot be an expert of AI, computational design, virtual reality, or digital fabrication. It's not possible. You need to find your voice, and create your own vocabulary, and you need to choose what's the best thing for you, what according to your, let's say, voice.
Yeah, that's an amazing thought, because I've seen how you're saying social media today, it's taking over people's lives. I see a lot of competition. Absolutely. Only because social media is always there, and you always see who's doing what project they're working on.
And also social media, they are like leading us into this kind of gamification, because we are living according to likes or views, and so that's why we need to stop for 1 second, and we need to understand if competition is something healthy or not. I don't think so. I think that we should be more creative and less competitive. It's not about winning something. And so I think this is the main advice that I want to give to students, or it's like more creative and less competitive.
Awesome. Thank you so much. That was such an interesting conversation.
Thanks to you for this opportunity, and it was really, really interesting also from my side. A great pleasure.
Thank you for sharing everything that you know. I really, really appreciate it.
Thank you so much again.
Guys, thank you so much for listening. That was episode number 5 with Arturo Tedeschi. And if you're not following yet, you have to follow The Archaeologist on social media. Do so right now. We're on Instagram, Twitter, Facebook, Pinterest, and many more. Also, you should go to our website, thearchaeologist.com. See you on the next episode, guys. Goodbye.